Today we're looking at Gauss-Jordan elimination, which is one more way to use matrices to solve systems of equations. And we're going to practice it manually first, but then I'll also show you how we can use technology in order to solve systems of equations quickly and efficiently. The Gauss-Jordan elimination is interesting because you really don't need to understand a lot about matrices in order to use this method. So we're going to walk through an example with a 3 by 3 system. So I have the three equations written down here, and I'm going to just walk through the steps and talk you through the steps as we solve this problem. So the first step is to write the systems of equations as an augmented matrix. And by augmented matrix, we mean this. We're going to write the 3 by 3 system of the coefficients. And in the same matrix, with a vertical line between, we write the constants. So it's one matrix that represents that system of equations with just the vertical line separating the coefficients from the constants. Our goal is to transform that matrix into reduced row echelon form. And reduced row echelon form for a 3 by 3 system looks like this. This part looks familiar. This is the identity matrix. So we want to get the matrix into that form where we'll have some real numbers, some non-zero, well, no, they might be zero, some real numbers on the right side like this. Because then we can say that x is equal to whatever value a is, y is equal to whatever value b is, and z is equal to whatever c is. And if you think about that, think about the equations. If we look at, for instance, the third row here, you can see that you've got 0x plus 0y plus 1z equals c. So you can see how that gives us z being c, and similarly for the other rows as well. So if we can get the left side of that augmented matrix into reduced row echelon form, we can just pick up off our answers from the right side of our vertical bar. So these are the three operations that we can use, and they mimic the steps that we use when we use elimination to solve a system of equations. The first thing we can do is we can interchange two rows. So we can switch row 1 or with row 2 or row I with row j. We're just switching their places in order to help us to get that reduced row echelon form. The second thing we can do is multiply a row by a constant, a non-zero constant k. And then the third thing we can do is to multiply a row by k and add it to another row. And when we write this, the result always goes in this second row. So the result goes, in this case, in row j. Okay, and we're just using I and j to represent the rows 1, 2, 3, 4, etc. of the matrix. So we're going to do a question now and walk it through its steps. So this is question 33 from the end of section 9.1 in our text. And so here are our three equations. And if you hear me pause in between, it's going to be just because I'm going to double check on paper that I've actually written the steps down correctly, because we do write down a lot of numbers, so you kind of want to be careful as you're going through the steps. So the first step is to write the system of equations in augmented matrix form. So my coefficients are 2, 2, 7, 2, 1, 2, 4, 6, 1, and my constants are -1, 2, and 15. So now I have 3 rows, and I want to, and we work left to right is the best way to do this. So if I look at the left column, I want that top 2 to become a 1 eventually, and I want the 2 and the 4 here, I want them both to become 0. So I'm going to do that first, is get those to be equal to 0. And if you think about getting row 2, getting a 0 in that first position, I could do that if I subtracted row 2 from row 1. So I'm going to write that as row 1 minus row 2. And again, the last number that you write down is the row where the result is going to go. And at the same time, to get row 3, I can do that by multiplying row 1 by 2. So 2 times row 1, and I'll subtract row 3 to put it in row 3. So we're going to do those one at a time. So at this point, I'm not changing row 1 yet, so I'm going to write it out as it is, 2, 2, 7, and negative 1. So now I'm going to look at row 2, and I'm taking row 1 and subtracting row 2 from it. So 2 minus 2 gives me a 0 as I wanted. 2 minus 1 gives me a 1. 7 minus 2 gives me a 5. And negative 1 minus 2 gives me a negative 3. So there's my new row 2, which is really nice because the first number is a 0, and now the second number is a 1, which is what I want it to be eventually anyways. Now to get row 3, I've got a 4 here and I want a 0. So if I multiply row 1 by 2 and subtract row 3, I can then get a 0 there. So 2 times 2 is 4, minus 4 gives me a 0 here. 2 times 2 is 4, minus 6 gives me a negative 2. 2 times 7 is 14, minus 1 gives me a 13. And 2 times negative 1 is negative 2, minus 15 is a negative 17. Okay, so now I've got zeros in the first column where I want them. I could at this point change that 2 to a 1, but I see with the other numbers that I have that I can get some zeros where I want them to be quite easily. So if I look at the second column now, I want this 2 to become a 0, okay? And I want this negative 2 to become a 0. So if we look at a row that's as far done as we can, so for instance, the zeros here, if we multiply them by anything and add them to the first row, it's not going to change that 2 at all. So that's okay. But what I want now is to get a 0 there. So notice if I take row 3 and add it to row 1, I'll get a 0 in that second spot that I want. So that will be a row 3 plus row 1. So that's going to go into row 1. So let's do that one first. So if I add those two rows together, I end up with a 0 here. Sorry, a 2 here, a 0 in the second column where I want it, and then a 20. 13 plus 7 gives me 20, and a negative 17 plus negative 1 gives me a negative 18. So now I have a 0 in the second spot of row 1. I'm going to leave row 2 alone because it already has its second column exactly like I want it. I've got a 0 and then a 1, so I'm going to leave it alone for now. But if I look at row 3, I really want to get a 0 where that negative 2 is. So because I've already played with row 1 and changed it, I'm going to use row 2 to get what I want there. If I multiply row 2 by 2, so 2 times row 2, and then add that to row 3, that will get me a 0 in that spot because I'll have 2 times 1 plus negative 2 to get 0. So 2 times row 2 plus row 3 is going to go in our new row 3. So 2 times 0 plus 0 is 0. 2 times 1 plus negative 2 gives me 0. 2 times 5 is 10 plus 13 gives me 23. 2 times negative 3 is negative 6 plus negative 17 gives me a negative 23. Okay, so I already have all the zeros on the left that I need. I've got zeros in the second column that I need. And so now I can start thinking, what can I do to get this even closer to what my final step should look like? Look at row 1 now. It's all even numbers. I want that 2 to become a 1. So really, I could say I'm going to multiply row 1 by a half. And that'll get me a 1 and a 0 exactly where I want it. Then if I look at row 3, I already have two zeros and I want that 23 to become a 1. So why don't I multiply that row by 1 over 23? And that will give me a 1 right here where I'd like it to be. So that will become 1/23 times row 3. So I'm just going to do those two operations. So I'm multiplying row 1 by a half. So I'm going to get 1, 0, 10, and -9. Row 2 I'm going to leave alone for now because the first two columns are good. And row 3 I'm just dividing by 23 basically, so that becomes a 1 and a -1. Notice how row 3 is in its finalized form. It looks beautiful. I've got a 1 where I need it and zeros in the rest of the spaces. All right, so now the piece I want to get rid of is this 10 in row 1. If I use row 2 to get it, I'm going to end up messing with that 0 in the second column. So I really want to use row 3 to get it because I've got zeros in the first two columns, so they won't change the 1 and the 0, which are good, which we want to keep. So I want to get a 10 in the third spot. So if I multiply row 3 by -10 and then add that to row 1, I'll end up with a 0 in that position where I want it. So let's do that with row 1. So I'll start with the 0. So -10 times 0 plus 1 gives me 1. -10 times 0 plus 0 gives me 0. -10 times 1 plus 10 gives me 0. -10 times -1 gives me 10. Minus 9 gives me 1. Okay, and row 3 is already good, so I'm going to keep it where it is. And we just need to look at row 2. Row 2 has 5 that I want to get rid of, so we'll do the same thing we did with row 1. We'll use row 3, multiply it by -5, and then add them to get that 0 in that location. So it'll be -5 times row 3 plus row 2. So we'll start with the far left. -5 times 0 plus 0 still gives us a 0 there. -5 times 0 plus 1 gives us a 1 there. -5 times 1 plus 5 gives us a 0. And -1 times 5 is -5. No, sorry, that's 5 plus -3 gives me a 2. So now, if we look at our final solution, this is row reduced form. So this looks like the identity matrix. To the left of the bar and to the right of the bar we have constants. So our final result is that x is equal to 1, y is equal to 2, and z is equal to -1. Now, that's using a manual method, and we will be playing with that and practicing that, but I want to just give you quickly the steps for using technology as well. So you're going to enter your matrix A, and really it doesn't have to be A, it can be any of the matrices on your calculator, but enter it as a 3x4 matrix. Don't worry about the fact that it's not going to show you the bar in the augmented matrix form. You'll just enter it as a 3x4 matrix. And then once you get your matrix, command up again, you're going to scroll over so that the math is highlighted instead of names or edit. And when the math is highlighted, you're going to scroll down until you find this command, reduced row echelon form of matrix A, and enter. And that will put the matrix into a reduced row echelon form, and then you can just read the answers from the right column of the matrix that appears. And that's using technology. So again, the technology is really easy, but it's really good to know where the technology comes from and why working with a matrix gets you the solution that you're looking for.